You know, it is absolutely wild to think about, but thousands of miles away, there is this invisible climate phenomenon brewing out in the Pacific Ocean right now, and it is literally dictating the weather on your very doorstep. In today's Explainer, we are diving deep into the global ripple effect of El Niño. We're going to look at how this one oceanic shift acts as a massive master switch for the world's most powerful storms. So, here is a quick look at the roadmap for our Explainer today. We'll start with the quiet season prediction, unpack the actual El Niño effect, break down the anatomy of a tropical storm, trace that global ripple, and finally, look at what's really in a name. Let's get right into it. All right, part 1, the quiet season prediction. We're looking at a pretty surprising forecast for the Atlantic this time around. Now, as you probably know, the Atlantic hurricane season typically runs from June 1st all the way to the end of November, and it usually peaks right around mid-September. During that window, those warm ocean waters act as fuel, right? They feed the tropical storms that eventually threaten the US and the Caribbean. But that brings us to a huge question. How could El Niño reshape tropical storms around the world this year? And why might the typical patterns we've come to expect be completely upended? Well, the forecasters at NOAA, the U.S. National Oceanic and Atmospheric Administration, are predicting a remarkably quieter than usual Atlantic hurricane season. Get this, they are forecasting a massive 55% chance of below normal activity, just a 35% chance of a near normal season, and a tiny 10% chance of above normal activity. It's a huge drop-off. And the hidden engine causing this massive plunge? You guessed it, El Niño. So let's unpack that in section 2. The El Niño effect, the real climate engine in the Pacific. To actually understand why the Atlantic might be so quiet, we have to travel all the way over to the Pacific. Basically, El Niño is the periodic warming of surface sea temperatures in the central and eastern tropical Pacific Ocean. It's part of a much larger climate pattern known as ENSO, or the El Niño Southern Oscillation. And the thing is, it's not a constant state. These events usually pop up every 2 to 7 years, and they stick around for about 9 to 12 months. When El Niño is active, it is so incredibly powerful that it actually pushes global average temperatures slightly higher, totally disrupting wind and rainfall worldwide. Now, what's really fascinating here is the contrast between the warm phase, El Niño, and its total opposite, the cool phase, known as La Niña. Honestly, it all comes down to the trade winds. Normally, these steady winds blow east to west across the equator. During a normal year, or a La Niña phase, these strong trade winds push warm surface water towards Asia. But during El Niño, those trade winds weaken. Sometimes they even reverse, and that allows all that warm Pacific water to just surge right back east towards the Americas. As we're going to see, that specific, gigantic shift in the Pacific is exactly what suppresses storm activity all the way over in the Atlantic. Which brings us nicely to Section 3, Anatomy of a Tropical Storm. Let's look at how these beasts are actually built. Before we trace that global ripple, we need to look under the hood at this incredible display of atmospheric physics. It's like a giant engine. It starts near the equator with warm ocean waters. That warm air rises, creating an area of low pressure right below it. As the air gets higher up, it cools off and gets pushed aside by even more warm air rising up from underneath it, which causes those crazy strong winds and rain. This cycle just gains momentum, feeding on itself, until it strengthens into what we officially call a tropical storm, which happens once winds hit 63 kilometers per hour. Eventually, the rotation gets so intense that it flings air outwards, forming that famous, eerily calm, low-pressure center we all know as the eye of the storm. Now, here is a fun fact that clears up a ton of confusion. Once those winds ramp up to 119 kilometers per hour, what do we actually call it? Well, scientifically speaking, hurricanes, cyclones, and typhoons are literally the exact same thing. Same exact physics, they just have different zip codes and local branding. In the North Atlantic and Northeast Pacific, we call them hurricanes, measured on a scale from Category 1 up to Category 5, where winds can roar past 252 kilometers per hour. Down in the South Pacific and Indian Ocean, they're cyclones. And over in the Northwest Pacific near Asia, they're known as typhoons, with the absolute worst ones getting dubbed super typhoons. All right, Section 4, Tracing the Global Ripple. Let's see how El Niño shifts this whole map. Knowing what these storms are, let's zoom out to the macro level to see exactly how El Niño moves the puzzle pieces around. Because it disrupts those trade winds and sloshes warm water around, the entire global map changes. Take Hawaii in the Northeast Pacific, for example. More storms actually tend to drift into that area following an El Niño year. Down in Australia and the South Pacific, there are usually fewer storms hitting the coast because the formation area shifts eastward toward the international dateline. That exact same eastward shift happens in Asia and the Northwest Pacific too. The total number of typhoons stays about the same, but they form further east. Meanwhile, over in the Indian Ocean, there are almost no major changes at all. But the absolute most dramatic shift, that happens in the Atlantic. A normal, average Atlantic season pumps out 14 named storms and 7 hurricanes. But El Niño actively suppresses that development. Historically, an El Niño phase triggers a massive 60% reduction in the number of hurricane days and a big overall drop in the intensity of those systems. That right there is the invisible hand of El Niño at work. But, and this is a huge but, we have to keep things grounded. Ken Graham, the director of NOAA's National Weather Service, summed it up perfectly. He warned, it only takes one storm to make for a very bad season. This is absolutely crucial to remember. A 60% reduction in hurricane days does not mean zero danger. If you live in a strike zone, you really cannot afford to just be complacent because you heard it's an El Niño year. And to truly understand why you can never get complacent, just look at this staggering number. $1.55 trillion. That is the estimated economic loss in the United States alone from hurricanes between 1980 and 2024. That is just astronomical. And obviously, far worse than the financial cost is the human toll. These storms have caused an average of 160 deaths per year in the U.S., totaling 7,211 lives lost over that same period. We're talking about the devastating impacts of storms like Hurricane Katrina back in 2005, Maria in 2017, and Helene in 2024. These aren't just weather events, they are some of the world's deadliest natural disasters. Let's wrap up with Section 5. What is in a name? The history of storm identification. When a massive storm strikes, its name kind of becomes etched into our history forever, right? But naming storms isn't just to be dramatic. It actually started as a purely practical way to help people quickly identify threats when they heard warnings on the radio or TV. Back in the early days, naming was totally arbitrary. They'd literally call a storm something like Anjay's hurricane just because it ruined a boat named Anjay. By the mid-1900s, meteorologists started systematically using alphabetical lists of female names. Then, in 1979, the whole system evolved again, and they introduced male names that now alternate with the female ones every single year. Today, the rules are super structured. The World Meteorological Organization manages 6 distinct alphabetical lists for the Atlantic, and they just rotate them every 6 years. But here is my favorite piece of trivia. If a storm is exceptionally deadly or destructive, out of respect for the victims and just for the sake of future clarity, they permanently retire that name from the list. It's like retiring a jersey in sports. That is exactly why you will never, ever see another Hurricane Katrina, Sandy, Irma, or Maria. And while the WMO handles the Atlantic, other regions across the globe actually tailor their own lists to their local languages and cultures, which just makes warnings so much more familiar and clear for their specific communities. So from those naming conventions to the devastating economic impacts, all the way down to the sheer physics of how they form, tropical storms are just incredibly complex. But for me, the most amazing takeaway from this whole explainer is the deep interconnectedness of our planet. I mean, think about it. How does an invisible ocean current, thousands of miles away, dictate the weather on your very doorstep? It is a stark reminder that when it comes to Earth's climate, there is simply no such thing as an isolated event. Every single shift in the Pacific sends a ripple across the entire globe. Keep that in the back of your mind the next time you hear a weather forecast. And remember, whether it's El Niño or not, always stay prepared out there. Thanks so much for learning with me today.